Good morning. I am Dr. Gangadhar H. Hugar, Senior Lecturer in Applied Science Department, Chandigarh College of Engineering and Technology, Diploma Section. I am here to talk on the corrosion preventive measures by internal corrosion preventive measures. Before to begin with, it is important to know what is the syllabus for diploma students who are studying in Punjab affiliated to Punjab State Board of Technical Education and Industrial Training. Here is the syllabus. A second chapter comprises of corrosion and which is of 10 hours duration, and according to the state syllabus, the total number of marks expected from this chapter is around 10 or 12. So, the content what we are going to talk on here, what you are going to study under corrosion is the definition of corrosion, theories of corrosion, then other forms of corrosion, preventive measures either by internal measures, external measures, protective coatings, and applications of corrosion protections and erosion in the boilers. However, in this lecture we are going to talk on the prevention and control measures of internal measures either by purification, alloying with corrosion resistance elements, heat treatment methods. As you know, this it is important to understand the what is corrosion before going to preventive measures. The deterioration of materials or the metal or alloy which we use, they lose the chemical their properties either by chemical attack or by electrochemical reactions with the environment. So, the deterioration of material or a metal alloy in its property by electrochemical or chemical reaction with environment is called as corrosion. There are some examples which we come across in our day to day life. We have seen rusting of iron, during which a brown scale of powder ferrosoferric oxide is formed on the surface of iron in presence of moisture and air. Then iron becomes weak and it loses its entire properties. That. So, you also must have witnessed development of a greenish bluish green color in case of the copper, in case of copper. So, the formation of green layer of basic carbonates, that is cupric carbonate on the surface of the copper is also an example of corrosion. So, this is a definition of corrosion. Let us see why metal corrode. In a sense, I can say the corrosion is nothing but a reverse process of metallurgy. So, in the light of metallurgy, what we can see is metal, we take metal ore and we will subject it to metallurgical operations, and then we get a metal. Suppose if you plot a graph of energy of these metal and ore, then this is a reaction what we carry out, metal oxides or metal sulfides or metal chlorides, sulfides, these ores are converted into metals by metallurgical operations. That is what reaction we carry out in industries. So, by doing it so, the metal ore changes to metal, and the energy content of the metal is more as compared to energy content of the metal ore. Therefore, you know that in the nature, if any material is at a higher energetic level, bound to lose its energy, and then it should be get stabilized. So, therefore, the reverse process is predominantly taking place, and ore thermodynamically which is stable state on metallurgical operations, we will get pure metal, and thermodynamically which is unstable state due to environmental effect, then our pure metal gets corroded. So, this is corroding, this is thermodynamically most stable state. As a result, metals most of them which we obtain from metallurgical operations are likely to be get corroded. I think this will be illustrative diagram why the metals undergo corrosion. So, if you just read here, the metals are in higher energy state than their corresponding ores. Higher energy states of metal make it relatively less stable than ore, or highly stable because it is in relatively lower energy state. So, this graph indicates the it is not to the scale, but just to give qualitative idea regarding how the metals are unstable and they bound to get stabilized by environmental effect. So, which we call it as a corrosion. And when you see this metal ore are converted into pure metals, and metal itself is changed into metal oxide or its ore. So, it is a reverse. So, therefore, we can describe this corrosion process as a reverse process of metallurgy too. So, why should we study the corrosion? Corrosion should be studied because corrosion of metal leads to loss of useful properties by the metal or metal alloy which we use, and its efficiency decreases drastically. To decrease in production rate, since replacement of the corroded part of the equipment is time consuming. For example, suppose if you manufacture iron and let us say it gets corroded, the amount of ore that you require to get that much amount of metal, the ore is sufficiently not been formed in the earth crust. As a result, this becomes a imbalance in the demand and supply, and therefore, it leads to a very imbalance situation. To increase in maintenance and production cost. So, we have to see the once we manufacture any metal and the product, its lifetime is very important, and it will increase, corrosion will increase its maintenance cost as well as its production cost. And if it is getting corroded, then the contamination of the product will be there. For instance, if I want to prepare a ferrous sulphate, because it will undergo oxidation further and it will become ferric oxide, ferrous oxide will be always having ferric oxide in contamination with it. So, this is one sort of example to say that every product which is metal or metal alloy happens to undergo will have some degree of contamination in it. So, it is important for the important to decrease this corrosion, we have to study the corrosion. So, important studies increase in useful life of metal part through corrosion prevention control measures. By study of corrosion, saving of metal worth many million rupees year in the whole world by following suitable corrosion preventive methods. The study of corrosion has ultimately led to the discovery of corrosion resistance alloy like stainless steel, bronze, etc. In fact, we came to know the alloys only in the venture of corrosion resistance material, then we invented the alloys. The electrochemical nature of corrosion process has been substantially used in industry as a etching process. For example, we want to mark anything on the glass, it would be by etching technology. Even printed circuit boards in which the rest of the material is being eroded by corrosion techniques. So, corrosion method will also be useful for the etching processes. According to a rough estimation, directly revenue loss due to the corrosion in India is estimated to be approximately 250 crore per year, and money spent on its prevention is about 50 to 70 crore per year. Such a huge amount is being spent in prevention of the corrosion, and a lot of research is currently going on, and every time we will be coming with one or the other useful material which can retard the corrosion. The development of titanic substrate insoluble anode TSAI at Secri led to a total power of saving of 6,300 kilowatt hour at a cost of rupees 22.7 billion up to March 2011. So, this huge data will help us to understand what corrosion damage it can cause. So, therefore, the study of corrosion becomes important in the field of engineering and technology. A central electrochemical research institute situated in Karaikudi, Tamil Nadu is fully engaged in the research and development of such materials which are corrosion preventive in nature by themselves. So, this institution is established in 1953 by, and it was dedicated to nation under CSI by Dr. Sarvapalli Radhakrishnan at that time. It is doing the wonderful research work in the field of this corrosion preventive measures. So, today's lecture is all focused on internal corrosion preventive measures. So, let us have in depth knowledge about what are the different types of corrosion preventive methods. There are some few methods of corrosion preventive measures such as modification of the environment. Second, modification of material properties, or it is called internal measures. Use of protective coatings, cathodic or electrochemical protection, corrosion preventive measures by material selection and design. Apart from this, there may be other methods as well, but these are important corrosion preventive measures. In the previous slides, you saw the modification of environment. What do you mean by that? Though corrosion can be stopped or retarded substantially by reducing by methods of modification in the environmental in which the material is being used. So, for example, you must have seen some silica packets are being placed which will absorb the moisture, and that moisture will prevent the corrosion. These are small examples. However, it is not always be possible or convenient to modify the environment to be non conducive to corrosion. For example, in chemical industry we use inhibitors, but use of inhibitors may lead to product contamination, which will severely affect the quality as well as price of the product. Therefore, to decrease or minimize such type of disadvantages of modification of the environment, it is better to modify the metal or alloys property while manufacturing itself, so that it can retard the corrosion rate. Therefore, modification of metal or alloy properties to retard corrosion rate can be called as internal corrosion preventive measures. So, internal corrosion preventive measures are nothing but the modification of metal or alloy properties to make them fit for retardation of the corrosion. So, let us take a look at the modification of metal material properties, which we can call it as internal measures or internal corrosion preventive measures. As the proverb says, prevention is better than cure. The corrosion preventive measures can be initiated while manufacturing metals or alloys. What are the methods by which you can modify the metals properties? So, will it be helpful for us even after modification? Certainly yes. What are those? Those are number 1, alloying, you must have heard about it. The second one is a refining of metals, that is purification method, and the third is heat treatment. Under heat treatment we have annealing, normalizing, hardening or quenching, tempering, astempering or tempering, case hardening, surface hardening, etc. From the point of view of your examination and understanding, we will discuss the modification of metal and material properties, that is internal corrosion preventive measures, in the lights of these following points, namely alloying, which can be passivating, neutralizing, inhibiting, then refining of metals as well as heat treatment methods. So, one of the best example what we can quote is alloying. For alloying is that pillar which we can see near the Qutub Minar, which is showing very little corrosion. So, how did they do it? So, it is just by alloying. What do you mean by alloy? Alloy is a homogeneous mixture of two or more metals along with some non-metals in proper proportions. Okay. So, alloys have wide range of advantages in resisting corrosion. However, every alloy do not resist all corrosives. The moment we say alloying, for example, let us consider stainless steel. Stainless steel means, as the name itself says, it is stainless, means it will not corrode. This is a misconception in the mind of some students. So, let us not elaborate the misconceptions. To remove these misconceptions, see, the alloys, that is stainless steel, is also undergoing corrosion, because alloys are nothing but homogeneous mixture of two or more metals, and when we mix them together to make it homogeneous, and that alloy is prepared or manufactured for a particular specific task or use. So, in that particular environment, that can be act as corrosion resistance, but the same alloy cannot be corrosion resistant to all atmosphere. Therefore, we have more than 30 types of stainless steel. Stainless steel, we say it is not one, it is a general name given to the given to alloy, which contain 11.5% to 30% chromium, 0 to 22% nickel, along with other alloy additions, because stainless steel is also not free from corrosion. Okay. So, chloride and other atmosphere, it too get corroded. So, what are the purpose of alloying then? Purpose of alloying are to improve the mechanical and physical properties of the metals, of course, corrosion and wear resistance to improve, electric and magnetic properties to improve these two mechanical properties such as strength and tensile strength, etc. For the improvement of such properties, alloying is done. And there is a misconception as well regarding magnetic property of steel also. So, some people think that the pure steel which is not corroding is not being attracted by magnet. For your information, there is no correlation between magnetic susceptibility and corrosion resistance. So, how mechanism by which the alloying can prevent the corrosion? The mechanism by which alloying of a metal enhances the corrosion resistance are maximum homogeneity. Greater the tendency to form alloy of a alloying addition, greater will be the corrosion resistance. For example, if you mix copper and zinc, we get a brass. So, they have greater tendency to mix up each other because of their approximate same size. As a result, it is easy and to make alloys of such metals to prevent the corrosion, not at the cost of their properties which we required in their service conditions. Formation of oxide films on the metal surface. also determines the corrosion resistance capacity. For example, in Durine, alloy of silicon and iron is very resistant to the acid due to the formation of silicon dioxide on its surface. So, alloying additions for increasing corrosion resistance may be for passivating, neutralizing, inhibiting. Let us see passivating. You must have studied that a passivity, that means certain metals exceptionally shows high corrosion resistance than expected from their position in chemical series. For instance, aluminum, chromium, cobalt, nickel, titanium, etc. are passive to prevailing corrosion environments, as they are capable of forming insoluble non-porous film on their surface. All these metals and their alloys exhibit outstanding corrosion resistance. For example, nickel steel and nichrome is one such example. Such examples, nickel steel composition has 36% nickel iron. It has a practically 0 coefficient of expansion, and it is used for making measuring instruments. Nichrome composition, nickel 60%, chromium 12%. It has good resistance to oxidation, heat, hence it is used in making resistance coils, heating coils, etc. So, neutralizing means addition of titanium, niobium, tantalum to the steel forms respective carbides and makes the stainless steel corrosion resistance. Sulfur is one such non-metal which is not expected to be present in the metal or alloy, because it develops cracks, that is a corrosion as well. This problem can be reduced considerably by addition of manganese and copper to reduce the sulfur percentage. The sulfur percentage in steel is can improve only machinability, but it is only for the purpose of that we cannot keep it for longer time. However, the sulfur impurities has to be removed to the maximum extent. The third inhibiting method, addition of arsenic antimony in brass prevents dezincification. Zincification means selective removal of one of the component of an alloy, leaving behind the other with the help of corrosion medium known as dezincification. So, these are the methods of alloying. Let us come to the second, where we will the refining the metals. Refining of metals means purification of metals. When metal or alloy are manufactured, these are generally heterogeneous. As you know, heterogeneous can give provision for local corrosion to take place, development of electrochemical cells which enhances the corrosion. Therefore, heterogeneous and consisting of two or more phases, either as a component or as a impurity present in them. Separate phase in metal or alloy can lead to development of local galvanic cell. So, the corrosion resistance of the metal considerably decreases. In other words, pure metals which galvanic couples are not formed are much higher corrosion resistance than the impure metals. Let us consider an example, that is the loss of weight by aluminum metal rod of different purity kept in contact with 20% of hydrochloric acid solution.